So here we shall give some more examples on using derivatives as rate of change of quantities. So the first example is a water tank. A water tank has the shape of an inverted right circular cone of an inverted right circular cone. Inverted right circular cone means it is somewhat like this. So it is an inverted right circular conical water tank we have. So cone with its axis vertical and vertex lowermost. Vertex lowermost. So the axis will be this one. The axis is placed vertical and the vertex is the lowermost point. So its semi vertical angle is tan inverse 0.5. It means that the semi-vertical angle means this angle, which is theta. Let's say this is alpha. So alpha equal to tan inverse 0.5. So I can say that tan alpha will be 0.5 here. Semi-vertical angle. So the full vertical angle will be 2 alpha. So here it is told that water is poured into it at a constant rate. Water is poured into it at a constant rate of 5 meter cube per hour. Then find the rate. At which the water level. Find the rate at which the level of the water is rising. At the instant. When the depth of the water in the tank is 4 meters. So it is told that, let's say, the height of the cone is suppose small h, and the radius of the cone is small r, and it's told that water is poured So it means that the rate of increase in the volume dV by dt, the rate of increase in volume with time, rate of increase in volume of water with time, with respect to time, that is dV by dt, that is equal to 5 meter cube per hour. That is given. So we have to find the rate at which the depth of the rate at which the water level is rising. It means we have to find dH by dt. dH by dt we have to find when the depth is h is 4 meters. When the depth of water in the tank is 4 meters. H is 4 meter. So that we have to find. So now we know that the volume of the cone, that is equal to 1 by 3 pi r square h. And here it is given that tan alpha. Now tan alpha we can say that will be equal to r by h, which is perpendicular by base. So that is given as 0.5. So H is equal to R 2R. H is equal to 2R, I can say. Or we can say that R equal to H by 2. So now therefore the volume we can say that is equal to 1 by 3 pi R square pi H square by 4 into H. So that would be equal to pi H cube by 12. So volume is pi H cube by 12 meter cube, that we can say. Here we have assumed that let the height of the cone is H meters and radius is R meters, and radius be R meters. So therefore from here dv by dt, that we can say that will be d by dt of pi H cube by 12. So that is equal to 5 meter cube per hour, that is given. So the rate of increase in the volume is constant actually. So therefore this will be pi by 12 is a constant, so it will come outside, into d by dt of H cube. So that is 5. So therefore I can say pi by 12 into 3H square into dH by dt. Here we are applying the chain rule actually. So that is equal to 5. So therefore we can say that pi H square by 4 into dH by dt, that is equal to 5. So therefore dH by dt, that we can say that will be equal to 5 4 the 20, 20 by pi H square. So therefore the height, the rate at which the height of the water level is rising, that is equal to at H equal to 4, that we have to find. So that is 2 into 20 by pi into 20 by pi into H square, that is H is 4 square. So that will be 20 by pi, we can take it as 22 by 7 into 16. So that will be 20 by 22 into 16 into 7. So that would be approximately 4 4 the 16, 4 5 the 20, that is 35 by 88 meter per hour. So therefore the final answer is that the rate at which the level of water is rising is 35 by 88 meter per hour when the depth of water in the tank is, 4 meters. Water in the tank is 4 meters. So hope you have understood the concept. And then we shall solve one more example based on this. So suppose it is asked that a man of height 2 meters walks at a uniform speed. A man of height 2 meters walks at a uniform speed of 5 kilometers per hour away from a lamp post, which is 6 meters high, and then find the rate at which the length of his shadow increases. It is being asked to find the rate at which the length of his shadow increases. The length of his shadow increases. So now here we have a lamppost and here we have the man. So the man is running at a uniform speed The man is running at a uniform speed from the lamppost. Then the length of the shadow will be this. The length of the shadow, I can say that is L, and the height of the lamppost, that is 6 meters, and the height of the uh, man, that is 2 meters. And then we can say that suppose this angle is theta. So the man is running at a uniform speed. Let's say this is x, this length is x. Then therefore from this triangle we can say that tan theta. So this is a right angle triangle, this is also a right angle triangle, therefore these two are similar triangles, therefore you can say tan theta, that is equal to 2 by L, that is also equal to 6 by x plus L. So therefore 2 3s are 6, so therefore we can say that 3L, that is equal to x plus L. So therefore x is equal to 2L. So now it is given that the man is walking at a uniform speed. It means that dx by dt, it means the rate at which the man is running, that is 5 kilometer per hour. It means that the rate at which the distance in between the lamppost, since the lamppost is fixed, it is fixed. So it means that from the lamppost, the rate at which the distance from the lamppost is increasing, that is dx by dt, that is equal to x. Then no, that is equal to 5 kilometer per hour. This is given. Since the rate at which, since it is the rate at which the distance of the man, rate at which the distance of the man from the lamppost is increasing, from the lamppost is increasing, is 5 kilometer per hour, obviously. So now the length of the rate at which the length of the shadow increases, it means we need to find dl by dt, that we have to find the rate of change in the length of the shadow. So now from here we got x equal to 2l, therefore l equal to x by 2. So therefore if we take the derivative on both sides with respect to t, so that will be dl by dt, that is equal to 1 by 2 into dx by dt. So that is equal to 1 by 2 into 5 kilometer per hour. So that is equal to 2.5 kilometer per hour. So therefore the answer is that the rate at which the length of his shadow increases, the rate at which the length of his shadow increases is 2.5 kilometer per hour. So hope you have understood the concept, how to use derivative to find the rate of change of certain quantities. Thank you.